Hey, we're back with Azure in the Enterprise. Today I have with me Ahmed Sabbour. Hey, Ahmed, how are you?
Hey, how are you?
And today we're going to have Ahmed walk through how to design a secure cloud-native application using Kubernetes on Azure. So we'll see you in a second. So we're back. So Ahmed, can you tell us a little bit about what you do at Microsoft, and then we'll go ahead and right into your awesome drawings.
Sure. So right now I'm a product marketing manager on the Azure Kubernetes service and the Azure Red Hat OpenShift teams. So I do lots of things with containers. And before that, I was like more on the technical sales side, but I've been a technical person for my entire life.
Yeah, you were an Azure Global Black Belt for a while, right?
Yes, I was.
Yep. And so let's go ahead and flip over to what you have drawing for us today.
All right. So just to get started, let's say you wanted to create an application and to deploy this to the cloud, and you decided to adopt container technology. So how do you actually get started? So let's say that you as a developer, you have your code you're developing on your local machine. Then you push this source code to some source control repository for good measure, whether that's GitHub or somewhere else. But you just do that. And you can set up some CI/CD process, a continuous integration and continuous deployment process on top of that to actually take that code and build this using the CI/CD process into a container image, which then gets pushed into a container registry or an image repository somewhere. This could be anywhere. This could be Docker Hub, or if we're using Azure, this is naturally going to be Azure Container Registry. So Azure Container Registry, or ACR in short, it's a geo-replicated, highly available container registry that you can use for all your container projects. So once you have your image in the container registry, where do you actually go from there? You need to run it somewhere. So on Azure, you can deploy this image to Azure Kubernetes service. So Kubernetes, if you're not familiar with it, it's a container orchestrator. The purpose of the container orchestrator is to take container images and deploy them on a cluster of machines, while also making sure that the resource utilization is respected, that these machines, if one of the machines goes down, the workloads get migrated to another machine so that it can maintain the uptime as well as the scalability requirements of your application. So on Azure, the Azure Kubernetes service, it's a managed service for Kubernetes, and it allows you to do so. So from that point forward, the deployment pipeline would then use that definition that you created when, for example, if you're using GitHub Actions, it will deploy this container image. But first, it would create a namespace. So a namespace in Kubernetes, think of it as like a project, or it's a boundary where a bunch of related application components live together. You can apply some security constraints on the namespace, some resource constraints on the namespace, and in general, it's best practice to deploy each application in its own namespace. So the way this works is that within this namespace, you'd be creating a deployment. So a Kubernetes deployment defines where are the images that you want to be deploying from. So in this case, let's say you're deploying this application and the images are living on Azure Container Registry. So in the deployment definition, you would say that, hey, these are my images. These are my images stored in this container registry, and this is how you can authenticate against this container registry. Deployments manage pods. So the pods are the smallest unit of control within a Kubernetes cluster. And the pods actually what run one or more containers. The pods would then initiate the image pull so that they can get the image outside of a Azure Container Registry and actually deploy them in your deploy that app to your cluster. Once this is running here, if you want to expose this application to the outside world, you would create a Kubernetes service. So a Kubernetes service is it's a way that you can load balance traffic across pods that probably are deployed across multiple nodes in the cluster. The service is able to direct traffic to the right node, which hosts the pod that is running your application, based on a mechanism called labels. So it can identify where the applications are hosted.
So now that you've got this up and running, it's applications aren't. It's not just an app. Obviously, apps work on data. AI apps acts on data, and then that turns on is often used by apps. So, you've got an application theoretically running here. What are kind of the options for hosting my data workloads in Azure? I know some people that may be super happy about Kubernetes being the operation control plane. They run, the database right inside of AKS, or what are the options, and why would you pro-con either internalize your state to the AKS cluster or externalize, and how?
So while you can certainly run a number of databases within the Kubernetes cluster, like for example, you can spin up a MySQL container image and run it there. The better option would be to rely on a managed service and externalize the state outside of that cluster. The reason being is that containers are, because they're lightweight, it's a lot easier to automate bringing up and down services and applications if the state is stored outside of the cluster. So think of it this way: if you're able to go ahead and delete this cluster and then redeploy it and redeploy every workload that comes with it comfortably, you're in a good shape, because then you're able to respond easier to disasters. You're able to scale out and stamp out additional locations to deploy your applications a lot easier than if your state is actually inside the cluster, and then you have to worry about, okay, now what? How do I move this data, or how do I back up my database from within the container? Containers do not necessarily make it any easier to manage databases. Whatever work you would be doing to manage the database, if you were running this on a virtual machine, you'd still have to do that on a container. So for that reason, you can connect your application to a number of managed database providers on Azure. So whether that application is using PostgreSQL, if it's using MySQL, or let's say something like MongoDB, you can leverage these managed services from Azure, as well as enrich your application with things like AI services, with cognitive services, while focusing on what you do best, which is actually coding the app versus trying to maintain that structure on a cluster. At the same time, you can configure monitoring and logging through built-in Azure Monitor, so that you can set up alerts and identify or understand how the cluster is working, and in case anything comes up.
And so then from here, tell us a little bit about how you start to interact with other services, either in other subscriptions or the other services in your subscription.
Yeah, so an Azure Kubernetes service lives within a virtual network, an Azure virtual network, and the nodes that you deploy within that form your cluster are actually living in a subnet, and then this service that you create as part of your deployment, it actually integrates or interacts with an Azure load balancer. So the services create rules in the Azure load balancer, which lives in its own subnet as well. And then this allows you to leverage a managed load balancer, in this case, which is the Azure load balancer, to expose those services to the internet, or even to other like consumers within the same virtual network. Now, an Azure load balancer is a layer 4 load balancer. So if you need to get more capabilities through a layer 7 load balancer, you can then create this, integrate this with something else like an ingress or an Azure application gateway. When it comes to securing your application, there are a couple of points that you can do. So Azure Security Center integrates with the Azure Kubernetes service. So it can surface vulnerabilities that are detected within your application or within your cluster deployment. It can detect bad configuration as well. Additionally, Azure Security Center also integrates with the Azure Container Registry. So in case you are building your application against a container image that ends up having a vulnerability of some sort, Azure Security Center will scan your container registry, and then it will alert you if that's the case, so that you can fix that by updating your container registry-based image. When it comes to securing access to the cluster, you can configure role-based access control against Azure Active Directory. So by doing that, your developers can then use their Azure AD accounts to be able to interact with the cluster. You can assign user and groups and do a lot of neat things when it comes to authentication by integrating with Azure AD. Also, since you're exposing this application to the internet, you can leverage something like the Azure Application Gateway and enable the Web Application Firewall functionality. When you do so, the Application Gateway then filters all of the incoming traffic into your cluster, and it's actually able to detect and block attacks that common attacks that work with the OOS, for example, attack vectors. So inbound traffic will flow through the application gateway in this case. And what about securing your outbound traffic? For many of the customers, the situation is that they have rules that they need to secure any traffic that goes outside of the cluster as well. So for that case, you can integrate with the Azure Firewall, and then all of the egress traffic would then pass through that Azure Firewall, depending on the rules that you allow in there, so that you are monitoring actually all of the traffic that's coming in and going out of your cluster in that case, between the cluster services and the internet. And then naturally, because you enabled the Azure Firewall, the only way that external traffic would be allowed to, let's say, your databases or security center or container registry, you have to use either for services that are enabled with Azure Private Link or Azure Service Endpoints, the traffic would go through either of these connection choices.
And I think the other thing here that I notice is there's fairly often where you have the firewall subnet that for large customers, they may have a separate subscription doing like a hub and spoke, where they may have that firewall or other appliances or CMs, things like that, and maybe some shared services for the enterprise. So that way, you may have AKS clusters or other services and multiple subscriptions going back to a hub where maybe that firewall is pinned. And I think the other thing that to me sometimes happens is just planning your IP configuration and your address spacing, so that way you don't run into that between your on-premise, your hub, and your spokes.
Yeah. And one more thing, it's not on this diagram, but access to many of the Azure services can actually be done through managed identity now. So securing let's say your connection strings can also be done through Azure Key Vault. So you can actually store sensitive information on Azure Key Vault and then pull those from Azure Key Vault directly into your Azure Kubernetes service on the application that's running on your Azure Kubernetes service, so that you don't even have to store or expose these sensitive connection strings within the application or store them in the connections.
It's one less thing you have to go either configure or write a little bit of code or do a couple extra hops for, which is really nice. Where, if somebody wants to kind of go learn more about generically architectures of Azure Kubernetes inside of an enterprise, or where should they go to learn more?
So we have a great set of documentation on the Azure Architecture Center. So in the Azure Architecture Center, you'll have lots of best practice and reference architectures for designing and securing applications. We also have a number of customer use cases that are published on customers.microsoft.com, where you'll find other customers who have gone through similar experiences of building applications and what did they learn out of them, and also like we actually see the architecture itself in the customer story.
Awesome. Well, thanks, Ahmed. We'll get this out. Anything else you want to leave us with before we go? And then we'll send links out to especially the Architecture Center and the other places you mentioned.
One last thing that we recently also released is that once we start having multiple of these Kubernetes clusters, you might want to apply some governance policies on them. And for this reason, we have created this integration with the Azure policy. So now you can actually apply many of these governance policies. For example, that all of the deployments need to have certain labels applied on them, or all of the clusters need to have this sort of daemon set running in there because it's mandatory for my organization to run. Right now you can control this with the Azure policy. There are a number of built-in Azure policies as well that can govern, for example, resource usage across namespaces. So from a control perspective, you can apply this at scale, and from a central location from the Azure policy.
And so is that something where, as a customer, I would typically use that maybe to require certain daemon sets running for, third-party, fairly common Kubernetes ecosystem things running on the clusters?
Yeah, so it's leveraging the Gatekeeper project, the open source project Gatekeeper. You can apply lots of rules that can help you do that exact same thing.
Awesome. Well, thanks, Ahmed. We'll get this out and get a bunch of links, and I'm sure we'll see you again soon because there's a bunch of other questions that I have that I want more drawings of.
Thanks, Lai.
Take care.